students, today we are going to talk about atomicity. And from the definition of atomicity, atomicity is the number of atoms in one molecule of an element. The number of atoms in one molecule of an element. That is the definition of atomicity. So, we have atomicity of some gases like helium, nitrogen, and oxygen. The atomicity of helium is 1, while that of nitrogen is 2, and that of ozone is 3. So, let's move on. Molar gas volume. The molar gas volume is another subtopic in the topic the mole. So, the molar volume of a gas is therefore the volume occupied by 1 mole of any gas at a particular temperature and pressure, normally at room temperature and pressure. So, 1 mole of oxygen is equivalent to 22.0 decimeters cubed at standard temperature and pressure, and 1 mole of nitrogen is equivalent to 24.0 decimeters cubed at RTP. So let's look at an example. Calculate the number of moles of oxygen gas present in 4.8 decimeters cubed of the gas at RTP. Calculate the number of moles of oxygen gas present in 4.8 decimeters cubed of the gas at RTP. So this is what you are going to do. You will say 1 mole of oxygen occupies 24.0 decimeters cubed at RTP. What about the volume given, which is 4.8? You take 4.8 decimeters cubed over 24.0 decimeters cubed times 1 mole. You are going to get 0.2 moles. Those are the number of moles in that question. So, let me give you a question that you'll solve on your own. Calculate the mass of carbon dioxide present in 5.6 decimeters cubed of the gas at STP. Calculate the mass of carbon dioxide gas present in 5.6 decimeters cubed of the gas at STP. So, let us look at something else. Combining volume of gases. Combining volume of gases. In combining volume of gases, we shall look at Gay-Lussac's law. Gay-Lussac's law. And Gay-Lussac's law is one of the longest law in chemistry that you are going to handle. So, another thing to take note of, you should know how to state this Gay-Lussac's law. Gay-Lussac's law. You should know how to state it. And it states that when gases react, they do so in volume that bear a symbol ratio to one another and to the volume of the product if gaseous, temperature and pressure remaining constant. Temperature and pressure remaining constant. It states that when gases react, they do so in volumes that bear a symbol ratio to one another and to the volume of the product if gaseous, temperature and pressure remaining constant. So in Gay-Lussac's law, the temperature and pressure must be constant. Temperature and pressure must be constant. Temperature and pressure must be constant in Gay-Lussac's law. So let us look an example involving Gay-Lussac's law. In an experiment, 20 centimeters cubed of sulfur oxide are found to react completely with 10 centimeters cubed of oxygen to produce 30 centimeters cubed of sulfur 6 oxide. Determine the equation for the reaction. Let me repeat the equation. In an experiment, 20 centimeters cubed of sulfur oxide are found to react completely with 10 centimeters cubed of oxygen to produce 30 centimeters cubed of sulfur 6 oxide. Determine the equation for the reaction. So the equation for the reaction is between sulfur oxide and oxygen. Sulfur oxide plus oxygen to produce sulfur 6 oxide. They are both gases. Produce sulfur 6 oxide. They are both gases. Produce sulfur 6 oxide. To produce sulfur 6 oxide. Must write the state symbol. Sulfur oxide plus oxygen to produce sulfur 6 oxide. Now that is the equation for the reaction that will take place. So they are saying that in an experiment, 20 centimeters cubed of sulfur oxide are found to react completely with 10 centimeters cubed of oxygen to produce 30 centimeters cubed of sulfur 6 oxide. Determine the equation for the reaction. Now that is the equation. So the equation must be balanced. The equation must be balanced. So they are saying 20 centimeters cubed of sulfur oxide, 10 centimeters cubed of oxygen. 20. Here is 10 centimeters cubed to produce 30 centimeters cubed. So this is what you are going to do. To balance the equation, here you should have the knowledge you should have the knowledge on how to balance the equation. You should know how to balance the equation. So this is what you are going to do, guys. You will divide by both sides by 10 by 10 by 10. So the balance equation, the equation that is required, which is balanced, is 2 sulfur oxide plus oxygen gas, which is going to give you 3 sulfur 6 oxide. The equation is balanced. 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 The equation is well balanced. So the next thing that you are going to look at is, let me give you some of the key points in this topic that you need to know. NB, if you have a pen, you can write somewhere. NB 24 liters, 24 decimeters cubed, which is the same as 24 liters or 24,000 centimeters cubed at room temperature. At room temperature and pressure is the same as 298 Kelvin. That is 1 mole of all gases is equals to 24 decimeters cubed at RTP. The second thing, 24 decimeters cubed, 22.4 decimeters cubed at STP is just the same as in degrees Celsius, 0 degrees Celsius or 273 Kelvin at STP. That is 1 mole of all gases is equals to 22.4 decimeters cubed. 22.4 decimeters cubed. Now let me draw for you a table that you'll be using in calculating Gay-Lussac's law problems and some of the simple arithmetics, including Gay-Lussac's law. Here we are going to draw a triangle. It's a triangle that we will be using in calculating Gay-Lussac's law. To calculate Gay-Lussac's law. So in this triangle here is volume, number of moles, then here molar gas volume. This triangle will be helping you in calculating some of the problems involving Gay-Lussac's law. Volume, number of moles, then molar gas volume. Volume, number of moles, then molar gas volume. So let's look at another example. What volume of hydrogen gas is obtained when 0.24 grams of magnesium reacts with excess dilute hydrochloric acid? So here what you need to do is to write the equation. You will first write the equation. You will first write